Hi everyone, I'm Lateefat Yusuff and welcome to Phase 3 of my Data 606 capstone project, where I'll be researching foodborne disease outbreaks in the United States. So as a recap from Phase 2, I did some data cleaning and exploratory data analysis where I got rid of any missing values and columns that I didn't need. And for exploratory data analysis, I was able to figure out the states that had the greatest number of fatalities, the greatest number of outbreaks, and the percent of outbreaks in each state that actually led to fatalities. I was also able to see the most popular foods that cause an outbreak and species type. So in this phase, I focused most of my attention on getting the data ready for the models and training it into a model. So one thing I've done is select all records that have a confirmed status. So that's important because I wanted to have a model that is generated based off of outbreaks that have been confirmed and whose species and which food type had been confirmed. The next thing was column selection. In my last presentation, I decided to take out the ingredient column. However, after some thinking and going through the data more, I realized that this column is actually more useful than the food column because this gives a more standardized name and a more detailed specific name than the food column. So I've decided that I'm actually taking out the food column and leaving the ingredient column. Next, I focused on the location column. There were many entries that were a little bit complex and would make it hard for me to train a model. So, for example, there were some entries that said restaurant, fast food restaurant, and so I changed that to just say restaurant. And then there's also some that said like restaurant, fast food restaurant, school, college, university. So I had to do some, some thinking on my own to figure out what would be the best name for this entry. So I had to make some educated assumptions and understand that these are maybe fast food restaurants on college campuses. So in this case, I would change it to school, college, university. And then after finalizing my data set, I ran the same exploratory analysis test from phase 2 and got similar outcomes for states with the greatest number of outbreaks, states with the greatest number of fatalities, and the percent of outbreaks in each state that led to fatalities. And here I created a heat map, which is probably a better representation of the outbreaks by state rather than the list that I had in phase 2. So you can clearly see here that Florida and California are the states with the most outbreaks, and it also helped me draw attention to other states that I didn't initially notice, like Ohio. And here is outbreaks leading to fatalities across the country. Again, you see California is actually a lot darker red than Florida, and I hope to explore a little bit more into that and see why that is. And moving on to building the models. Following the exploratory data analysis, I constructed models that will train my data to predict where an outbreak will occur next, by food source location and also by state. Then also which food type will cause the next food outbreak, and when, meaning like which month, the next outbreak is likely to occur. So I began to construct a model to determine the location of the next outbreak. So to do this, I implemented different models to determine which performed the best. And prior to training on these models, I scaled the data to address the imbalance distribution of outbreaks per state. And so basically what I hope to get from just running the data through these models is just to see which model would be a great starting point for me moving forward and how to filter and narrow down my focus. So I started with logistic regression, and I got about an accuracy score of about 35%, which is pretty poor. However, I did not do any feature engineering yet or feature selections yet, so, which I hope to do in the next phase. I also tried gradient boosting classifier, which didn't really do any better. I got about the same score with gradient boosting classifier. And then XGBoost surprisingly performed worse than I thought it was going to do. And I think it has to do with, I noticed in the code, there was an error message that showed up that said that one of the classes had only one entry, which seems to be throwing off the model. So I do hope to get back to that and address that, so that way I can retrain using XGBoost and see if that improves at all. Also tested on a linear SVC, got a slightly better score of 66, and I don't really know if that's due to overfitting, which I need to address again by doing more in-depth parameter tuning and feature engineering and feature selection. So my next steps moving forward is just to focus on in-depth feature engineering and picking the best model. And once feature importances are determined, I'll retrain on these models, and I'll use the model templates for predicting the remaining two questions from previous slides. And the other steps that I'm going to be taking is to do more parameter tuning and more research to determine if I chose the best models, re-examine my chosen models to ensure that there's no overfitting or underfitting. And once the models are finalized, I'll create a comprehensive visualization of my end results. And I'll also be able to use the final feature importances to determine how large of a role contaminant species play in predicting disease outbreaks. And of course, most importantly, I'll begin to draw some industry conclusions and assumptions based on the results and highlight any faults in specific areas of the food industry. Okay, thank you guys for listening in, and good luck on your presentations.